So kind of a bug. That's what I'm trying to figure out. My check out if I want to delete it, if I want to stay there.
Do they?
Did you watch all of it?
I saw enough of it on Facebook. I like getting it third hand on Facebook. How are you guys? I know everybody's thinking about their XML stuff. Remember, it's a Unity exam, so we're just going to turn it in. I'm not going to have you show it. Put your exe files out there for everybody to look at. Then we'll have some time at the end of class, just a little bit of lab time in case you still need to work on it a little bit. But we want to get started on database stuff because, boy, we have a lot to do. We're in lesson 9, our first connectivity one. We have some important stuff that I wanted to show you here in our weekly module on Canvas. First of all, we'll be looking at this setup. It's got our URL for our Amazon web server that we'll be using as our database server. So if you're in another class like CIS151 that uses an AWS server, this one will be different. So you won't be using the same server for both classes. You could copy things back and forth if you wanted to, but they're separate because of the way things get charged. So if we have too many databases on one of those servers, we start getting charged a lot more. So we just keep everybody in a separate server. Okay, the next thing, let's take a look at it before we really get too far in. In November, we have 2 former students, Matt Smith and Kelly Stoops, and both of these guys graduated a couple of years ago, and they both work at Jack Henry. And they both work in Springfield, but of course, being at Jack Henry, they get to work from home, I think, a lot. But they're excited about coming in and talking to you guys and being guest speakers, and they want to let you know, what they went through and how the interview process worked for them and what kind of things they ran into, what kind of disappointments and great things they ran into, and give you guys some advice. So I set this up as a discussion. Don't worry, it's not a discussion like a discussion. The only reason I set it up as a discussion is so you could look at other people's questions for Matt and Kelly and try to come up with something different. So they'll be here on November 6th. They're going to come to the morning class on the 4th so that they are not out of the office for a whole extended period on one day. So if we can give them some questions beforehand, they can do it a little bit like a forum where they'll just kind of take you guys' questions and read them out loud and answer them. Plus then they know what you're interested in and what kind of stuff they should talk about, if they should talk about anything else. So think about this. Ask them important things. Try to not ask them, bless you, trivial things, but they both have gone through a lot to get where they are. They're not, you'll see when they get here, they're not the kind of guys that just fell into it, because they're super lucky or anything like that. And they're fun to talk to, bless you, because they just are real interesting. Matt has an awesome English accent, so it's cool just to listen to him and to think about, gosh, he's so far from where he started. Good, bad, or the other, he's far away from wherever he started. So think of good questions for them. You want to ask them, things like what they wish they had done, what they did that they thought was really helpful. What their day's like, what kind of stuff they work on, is it related to school? All those kinds of things. You can make it a really long question if you want. The next thing is an info link, and it says Riley's links to SQL training. And of course that worked at home, but it doesn't work here. So up at the top, in case anything ever loads like this, refusing to load, just click on the link at the top and it'll open it in a new page so that it doesn't get you stuck like that. Pearl Trees is just a site to organize stuff. And so I have a Pearl Trees folder for SQL. So in this SQL stuff is just all sorts of different training courses, information that I found over the years that just has to do with SQL. So as we get started with SQL or SQL, how many of you have not had a 250 class or are not in the 250 class? A couple, 3. And then I'm not sure about Christian. We'll find out. So in the morning, we just had 2. So you guys outnumber them. That's good. Everybody else is going to help you guys to get through it. The big thing is don't get overwhelmed because we're going to be talking about some stuff you don't understand yet. That's the way it is, but you will understand it. So, and we will make sure that you have all the commands and everything you need to get the programs done that we write. Now, if SQL is something you want to know a little bit more about before we go too far, there are lots of things to learn SQL. This is the Code Academy course on SQL or SQL, and I'm sure that some of it is chargeable now and some of it is free. I haven't looked at it lately to see if it's all still free. Here's an SQL course. It's an interactive online training for beginners. So there's lots and lots of training out there available for you to look at. But like I said, we're going to have most everything that you need already set up for you. So this is just if you want to dig deeper and know a little bit more about what's going on behind the scenes. And of course, when you take the 250 class, it'll all come together. Sometimes when we're working with technology, we have to leave some gaps until we get to come back and cross over again and fill in the gaps. That's how it works. Okay, then this ADO provider flowchart we may or may not refer to because things with the world of databases are a little bit different in C# than they were just a release or 2 ago. So let's look at this link here that is all these videos. It says Chapter 21, Overview and Walkthroughs. All of these videos are out here for your use if you want them. This first one is from the 201 class, which is about Excel and Access. So this is a video that's the introduction to using Microsoft Access as a database, if you're more interested in that. In this series, after the intro to Access, a database table is created in Access. We utilize that table to create an app in C#, and then we complete that app with update capability. On the other side, we take the same database table and create the same table in SQL Server, and we'll be using SQL Server in our unit. Then after we create the table in SQL Server, there's a video that shows how to convert the application from Access to SQL Server. Okay, so lots of videos out there for information, but they're all kind of a little bit different. We'll talk about that. Now, the other 2 things, just Quizlet and then your assignment. And in your assignment this week, we just want to create a class file and a table. It should not work. It's not an app that's going to be fully created yet. It's just the first steps of it, okay? So after today, you should know how to do all of that to complete that assignment. So what we're going to be looking at as far as accessing databases and data stores in C# is called ADO.NET. ADO stands for Active Data Objects. But they change things a lot when we're working with databases, some for the better. So we'll see how this is going to affect us. So what is a database? A lot of you have really good knowledge of database. Some of you are going to be beginning. First of all, a database is organized data. That's its purpose. That's its reason for being. So a database controls the disk space to store the data it organizes. That's a really big deal if you're talking about 20 billion rows in a table somewhere. You need a lot of disk space and it has to be managed correctly. A database management system is usually just a process that's running on a computer system, and a computer system that's running that database management system process is a database server. So the database server allows controlled access to the data, and it allows controlled update of the data. So if I'm using a database, I can say that these users can view the data but these other users can update it. And I can get down to a really fine level of which column individual people can update and view. So it allows me to really secure the data down to the level that I need to. Now, what kind of things does a database have? What does it have? It has tables. And tables just contain the data elements to store a specific entity or an object. So think about the classes we've been creating since last semester. Every time we create a class, we're saying this class defines an entity. So we could be able to convert that class entity into a database table. When we have one instance of an entity, like the student named Bob, that's going to be one row in our student table. And each table row has lots of columns or properties of the row. So our student named Bob might have columns like student ID, name, and graduation year, and things like that. When we're working with a database table, a row in the table is equivalent to a record, and a column is equivalent to a field. So it's just different terminologies for the same thing. So here is an entity relationship diagram. And these are the tables that are in our textbook. This one that we never use, I'm going to use it for this chapter, chapter 21. So we're going to create the tables that they specify in our book. Why? Because lots of reasons. But our textbook actually uses the newest way of accessing databases, which is going to be much faster and much more efficient code-wise for us to learn. So it's always a quandary. Do you guys want to learn the newest way, or the way that's used the most, or the really, really old way? So we always try to balance it. We're going to learn the brand new way. So these are the tables that we're going to create to match up with the exercises or activities in our book. So we're going to have one table that's called inventory. And in this table, we're going to have a unique key. So for every row in this inventory table, we're going to have a unique car ID. For each car that's in our inventory, you can think about this as a car lot where we have all these cars for sale. For each car that's in our inventory, we're going to keep track of the make, like it's a Toyota or whatever, the color, and the pet name. Do you guys have pet names for your car? Name it Roscoe? Nobody? You do? Oh. My sister always does, so I felt real guilty, so I named my Prius Beyonce because it's a little bit fancy. Oh no, I'm not very good at naming cars, but I thought I can do.
Cars, the only boys or girls?
Well, they're supposed to be girls. But then I told my husband, I don't know, you know, his truck might be one house sitting out there with Beyonce.
I don't think people name their trucks as often anymore because like cars aren't, or vehicles aren't as big. They were kind of the computers of their time where everyone that had one was really into cars.
Yeah, and they were super attached to it. I think that's
Yes, and then
true.
now it's just another item.
Yeah, my sister's had her car for God forever, and it hasn't aged. Do you name yours?
Yeah, my first was Sunshine.
Sunshine? Is it yellow?
Yeah, it's bright yellow. Yeah, it's I definitely took me. So my dad sent me some yellow cars when we got out of school.
That's fancy. Ooh, that's super fancy. I don't know. My sister's is, gosh, I can't think of what, but she talks about her car by name, kind of like it's a child. So I got to get used to it and remember its name. Okay, so we're going to have pet names on here. So I think they have a Rusty, is an old Rusty car. So we have some good car names. That's our inventory table.
You have to take your car for a walk.
Ah. Or yell at it when it won't start or do weird things. Oh my gosh, I didn't tell the class this morning when we were talking. Beyonce almost caused a wreck yesterday. It was not my fault, but so almost got crashed. I can't, you know, I turned right off of the road that I'm, Talpa that I'm sitting on and the stop sign, and there's kind of some railroad tracks off behind there that people are coming from Craft, and there was a car back over those railroad tracks. And when I turned right and looked back in my rearview mirror, that car was up on the sidewalk, like this far from me. So I think it almost hit. So I think that someone was on their cell phone, obviously cell phone related, and didn't slow down. Or I might have pulled out in front of them a little bit prematurely. One or the other. So we're going to have an inventory table. And then when we work with people, we're going to set up a customer table for those people. Now, again, we're going to have a customer ID just to have a unique key for every customer that we have. And all we're going to keep track of for customers is first name and last name. So we're not keeping track of a whole bunch of information. Whenever someone buys a car, we're going to create a row in our orders table. So our orders table is a link table. It links our inventory to our customers, right? So we know who bought what car. So in our orders table, we're going to have a unique key called order ID. And then we're going to keep track of the customer ID of the customer that bought the car and the car ID of the car that they bought. So we'll be able to tell who bought what car. Now, whenever we look at this entity relationship diagram, beside the entities, we see relationships. So we can have customers place orders for cars, and we have inventory that fills the orders for cars. And so we can see what our relationships are. We can't create a row in our orders table unless a customer with this customer ID already exists in our customers table. And we can't create a order for a certain car ID unless that car ID already exists in our inventory table. So those kinds of problems, referential integrity problems, would cause issues in our database if we tried to do something like that that violated those rules. Now, each of our tables, if you see, has a primary key where that's the unique identifier for that table. And we're going to want the database to generate those primary keys for us. We don't want to come up with a unique key. We want the database to just say, oh, okay, I'll give you the next one. And then we have some foreign keys. And foreign keys are keys that are primary in a different table. So our orders table has foreign keys to go back to the inventory and the customer. So this is the database that we're going to create. Before we create it, a few things. Whenever we work with databases, relational databases like this, we're always using one language, SQL or SQL, which stands for Structured Query Language. When we're using SQL, we only have 4 different statements we can use. That's why it's okay that you guys haven't had the class before you start working with the database, because it's pretty limited. So we're going to have the select statement that retrieves data, and it's going to give us a list of results in a data reader. We have the insert statement that we can use to add new rows to our table. And in our tables, our ID will automatically be set when we insert a new row. We have the update statement that lets us change data in a row. And we have to be sure we use what's called a where clause to identify which row to update. And then the delete statement is the same way. To delete a row, we're going to specify the where clause to identify which row to delete. So just a basic select statement. We have some examples here. We have the keyword select, followed by the list of columns that we would like in our result set. The star or asterisk means all columns. After our column list, we have the from keyword. And after the from keyword, a list of the tables that we're going to use to select the data from. Finally, we can have a where clause to specify which specific rows we want. So in that last select statement, we only want to see the orders that are in order ID 1. And for those orders, we'd want to see the order ID and the model of car. So we should only get one row. Do what?
Could you, on the where clause, would you be able to use expression for that, like do every other row, like modulo or something? Or is it just like you have to find, like,
You could do math in it if you wanted to. Yeah, so your where clause could get really involved if you wanted to do things like that.
Something like where order ID divided by where the leftover, I can't remember.
Modulus.
Yeah, where the modulus is
Uh-huh.
not equal 0.
Yeah, you could do that. Yep. So pretty basic, lots we can do with it. And when you take the 250 class, lots more. But some basic things that we can do that won't be too awfully bad so that you can learn how to work with databases. Now, when we work with any kind of database, we need to be thinking about the layers that are involved. Down at the bottom is my database management system. We're going to be using SQL Server, SQL Server from Microsoft. The videos that you could watch if you want to, use Access database from Microsoft, which is a viable option for very small work group. You could also, depending on where you worked, you could use DB2 as a database management system on the mainframe or on many different size computers. You could use Oracle, because Oracle runs on mainframes, mid-ranges, desktops, all sorts of different sizes of machines. Many others, Postgres, Ingress, Sybase, SQL Server, blah, blah, blah. What's that? There's another one they mentioned, Free SQL or something they mentioned in our textbook. Doesn't matter, because all of these database management systems speak SQL. So once you know SQL, you know that SQL language, you can interact with any of these database management systems. Doesn't matter. You know how to talk to it. You talk SQL. So that's going to be our language. Now, our programs are going to have to use this SQL code to be able to communicate with the database management system. So C# has some classes already pre-built for us to try to make that easier. The ADO.NET classes. So that's what we're going to be using to access our database management system. There are classes set up for many of these different database management systems so that we can make things work seamlessly across the board in C#. We don't have to worry about whether the database management system is SQL Server or Oracle or Sybase. We're just going to use our ADO.NET classes. So we'll have the same thing as SQL. Now, there are lots of ways that you can access database using C#. Sometimes this makes people nervous. Do you guys like change? So to me, let me tell you, the thing that I've seen over my life, I've seen people that go to work every day and they do the same thing. You can see probably. But I've worked at companies where some people were, I think the most boring job I've seen is they were accounts payable clerks. Nothing against them, but they would come to work every day and they would sit down at a screen that would list all of the checks that came into the company that night. And then on another screen, they would have all of the invoices that the company has issued to all their customers. And they take this check and say, oh, customer 1234, customer 1234, this check must pay this invoice and this invoice, oh, and $3 of this invoice. And they type all that in, click. Then they go to the next check. Oh, customer 768. And they go find that customer. And they say, oh, this check must pay this invoice and this invoice. And they do that for 8 hours every day. Twice, they get up and take a break for 15 minutes. And once they get up and take a lunch. That would be torture to me. I don't know about you guys. But to me, that would be torture. Some people like that because they like that routine of going to work and doing the exact same thing every day and knowing exactly what they're going to do. For us in CIS, we are not that way. You need to enjoy change and be excited by challenges or you're going to be super stressed. Why? Because things are always changing for us. We always have new ways to do things, new tools to learn, new languages to learn. So, 3 manners of database usage that our book talks about. First, this connected interface. That's what chapter 21 is in our textbook. That's what we're going to do this week and a little bit of next week, talk about connected ADO.NET interfaces. Disconnected accesses a database is considered the classic ADO.NET. So that means if you go to work today and you look at somebody's code that accesses a database using C#, it's probably going to be using this method. This method is what all of those videos use. So this is like the method that was good up until a year or so ago.
The procedural coding.
Yeah, it just requires a little bit more work than this connected method. So the new method we're going to learn takes away a little bit of the work from this one. Now, the other option we have is using object relational mapping and the entity framework. And this is going to be chapter 22. We'll be looking at that way. So lots of different ways to access the same data. No matter what, in the end, we're going to be issuing those SQL commands to the database management system. We just have all these different ways of doing that, okay? So don't let it get you stressed, because it can be a little bit overwhelming that everything you look at does something a little bit differently. Try to find the similarities. Where's the SQL command? How is it getting sent to the database? What else is going on? Now, all of these types of data access have to have the using system.data specification. So that's where all of these data objects are. And they all have to do things in a certain sequence. So no matter which method we use to access the database, we got to connect. And when we connect, we're going to be using a connection string. That connection string is going to say, where's my database server? What's the name of my database on that server? And how do I log on to that server? Next, after we connect, we're going to run some sort of command, a SQL query or a non-SQL query. And then we're going to close that connection to dispose of all of the resources that were allocated to us while we had that database connection open. One thing that we need to be aware of, when we connect with this connection string, because we're connecting to an AWS server, we want to make sure that this information never gets loaded to GitHub, okay? So we use TFS. TFS is a local source code control system. So if your code is only going to TFS, it's not a problem. But if you also upload your code to GitHub to a public repository, you want to make sure that this connection string is eliminated from your code before it goes to GitHub. So either a git ignore, or you manually delete it, or you do something to clean it up. Last year, one of our best people in the capstone class did not know that, and there was several $1,000s worth of Amazon charges overnight to one of our little Amazon test accounts. So we've got to be super, super careful and make sure that that information doesn't get posted to GitHub. And GitHub has standard git ignores built for these kinds of things to make sure that they get pulled out of your code before it gets posted. So our big, oops, be careful about that.
I take it sometimes it doesn't work.
It was just a didn't know. You learn things. Okay, so let's make a database. First, let's find our URL. Here in Canvas, where it says set up SQL Server access, let's go to that link. Now in here, there are a couple of things. First of all, we have our SQL Server name, and here it is in this really long thing in bold. It's actually a little bit more than our server name. It's our server endpoint address to our Amazon web server. So it has our very long server name followed by our port number 1433. Now to use this is the server we're going to use to connect. And the tool that we're going to use from our desktop is called SQL Server Management Studio. So on your start menu, if you type in SQL, you might find it, but you might have to go to all programs and see if you can find it. We want This Microsoft SQL Server Management Studio 18. Be careful because I think the 17 was still installed on some of the computers. Make sure you find the 18. Do you see it? Now, when you can download this at home, the link is just right above our server name here. That link is to download SQL Server Management Studio. Now, in our textbook, while this is loading, I'll mention, in our textbook, they say that you could also install SQL Server. You don't need to do that because AWS, Amazon is running our SQL Server. You can get to it from here, you can get to it from home, so you're all good. Now, one place that you can't get to it from is your laptop on the wireless network. It is not open. Another place that you can't get to it from is some other classroom sitting on some computer, because our Amazon web servers are only open to these desktop computers in this classroom and the desktop computers in 107 and supposedly the tutoring center during the day from 8 to 5. So we don't have any access to any wireless networks or anything like that. About that, so you might send in message to the help desk.
So going off of that, if we were to do this at home, we wouldn't be able to get access to it after 5 o'clock.
At home, you're fine.
This is on their work.
It's just here. Just here. So yeah, at home, you're all good. It's just OTC blocking you. No, actually, they just won't let you through. So they're very worried about it.
I would think that at home would be the greater issue that they would block.
It's an Amazon web server, so they don't control it. So a couple years ago, we had so much trouble with the SQL Server on campus that we had to go off campus. And so they're very concerned about security issues with that because it's not an on-campus server. So we are limited to our access. Now, if you have trouble getting to it, I'm happy to email help desk, but we've gone around a lot of circles. So we're kind of to the point where students need to email if it's an issue. So that, because is it an issue or is it not? Now, another option you have is using your phone as a hotspot, because they said that was okay of a way to get it. Now, I have this weird server name left over in my server name, so I'm going to delete that. So how do I log on? On your SQL Server login screen, your connection screen, you want your server type to be set to database engine. You want your authentication to say SQL Server authentication. Now, we're going to copy that long string from Canvas as our server name. And if you notice, it does say CIS151-102 in that server name. So if you have other classes, you'll be able to tell the difference in which server is what. Now, your login name should be your username, just your initials and number. And then your password should be your number without any preceding zeros, leading zeros, because I used Excel, so it wiped out all the leading zeros. I didn't think about it. Let's see if everybody can get logged on. Bless you. So if it doesn't work the first time, you'll try it again. I think I've had to try twice every time I've connected to the server. So let me know if it does that to you. Okay, does everybody get connected? Did you get logged in and connected okay?
I'm still downloading it.
So downloading it, you won't be able to get to it through your laptop anyways. So you gotta use the desktop.
No, I got my hotspot on my phone. Right
Let's use the desktop so we can get going. Well, and then let that download happen offline. How about you? You connected?
I'm just gonna go off my data because I don't even want to.
You sure? You're hotspotting it? Okay. She might share, Peter. You guys might have to come up with an arrangement here to share with each other.
That password like way Takes forever to type.
Like to share? I was trying to get that virtual reality headset working last week and connected to Steam using mine, and my son was like, "Oh my gosh, you probably use that already."
It's almost done.
I think we have 20 billion minutes of carryover. Okay, so we should have some databases here. Let's take a look. Click the plus sign, and you should see a database for you. So click on it. Make sure you have security access to your database. Is it letting you access it? When you get to your database, you can click that plus sign and see if you have any tables. Right now, I don't have any tables. I just see more folders for like system tables and external tables and graph tables. I don't have any. Everybody working okay? It's like a miracle. This morning I thought, oh, I wish we'd have got further, and then I was like, what are you talking about? Everybody got locked down. Sometimes that takes a whole day.
I opened up database diagrams and it asked me if I wanted to put something in there, if there was something in.
So say yes if it wants to install something, because we're going to go to that in a minute. Okay, before we do that though, let's create our tables. I'm going to show you that diagram again. So we're going to create our inventory table first. So we're not going to have too many columns, just car ID, make, color, and pet name. No problem. So we have a lot of ways we can create a table. For this first time, we're going to use the graphical user interface. So under your database on tables, right click and choose new table. When you do that, over here in this query area, you should see a new tab come up, and this is going to be our table. Notice the areas of your screen, just like the other Microsoft products. You have all of your title bar and toolbar and everything up here. This Object Explorer is what we'll use to keep track of what we have in our database. And then here in the middle is where we'll create queries or do different things. So we decided that this table is going to be inventory, and the first field it's going to have is car ID. For our database, they're going to use upper camel case. And I know depending on who told you what the names of those things are, you might have heard something different. But for upper camel case means we're going to start with an uppercase letter for each word, including our first word. That's why it's upper. On ID, we're going to try really hard to always use an uppercase I and a lowercase d so that we don't get mixed up. And even in our book, there's a place where they use an uppercase D. All right, the next column over is our data type. If you choose to drop down, yes?
How did you get the properties and column properties to show?
I'm just clicked here. Are you not seeing them?
No, I don't have them.
This over here? I'm going to get rid of it. How's that?
Oh, wow.
Does that look more like yours? Because we were having trouble last time and we got to that screen, so I'll show you how to get to it in a minute. So in your data type column, notice that SQL Server allows for a lot of different data types. Being a database, it's responsible for storing, lots and lots and lots of petabytes of data. So it has to do it in the most performance-aware way possible. For us, we're going to make this car ID an integer, and we are not going to allow nulls. We have to have an ID. Now, because we wanted our car ID to be our primary key, we can right-click anywhere on that row and choose Set Primary Key. And now our car ID is our primary key. We still want the database, though, to generate that number for us. So down here in your column properties area, scroll down and find identity specification. Do you see it? We want to say this column is identity. It identifies our row. So I'm going to change that from no to yes.
So that's basically saying this is our name.
This is our unique key for this row. So it's not a name, but a number. But it's going to be set by the database. So right now it's going to start with the number 1 and up it by 1. Our owner said he didn't want anybody seeing that they were car ID 1. That would make it sound like we'd never sold any cars before. So he wants the first car ID to be 10,025 instead of 1. This morning people said, well, nobody'd ever see that number. Doesn't matter, that's what the owner said. Doesn't want 1 to show up. All right, so if we've got that set, we are all good with our car ID. The first car we put in inventory is going to have the ID 10,025. Now, our next column that we want to keep track of for our inventory is make. Our data type that we're going to use for make is going to be nvarchar 50, and we do want to allow nulls. After our make, we're going to have our color. We're going to have this column be nvarchar 50, and we're going to allow nulls. And the nvarchar 50 just tells the database management system to save it exactly as we put it into the column. Don't do any sort of data conversion for us. And that it could be up to 50 characters. Do what?
So it's like putting a literal.
And so it's just a string that could be from 0 to 50. And since it's varchar, the database will only keep what is actually there. So if we only put 2 digits in that field, it'll only keep those 2 characters instead of wasting space. Okay, and then the last column that we want is pet name. And it's going to be the same data type. And we're going to allow nulls. So we're ready to save our table. If your table looks good, it's like that. Lots of ways we could save it. I like controlling it. I'm going to right click on this tab and choose save table _1. And then I'm going to give it the name inventory. Now, if we miss that, we could rename our table. Right now, when we don't have any data in our table, we could change anything that we want. As soon as we put data in that table, a row of data, bam, it's going to be really hard to change it. Because it's going to be like, nope, you have data. You can't change me now. Okay, I'm not seeing my tables yet in my Object Explorer. So come over here and click refresh. After you refresh, you should see your inventory table. It should be dbo.inventory. DBO stands for database owner. Since this table is in your database, you're the owner. If you click the plus sign beside it to expand it, you should see the columns. Let's see what columns we have in our table. There we go, we have the columns that we put in it. And for keys, we should see that our car ID is our primary key. We just know we have a primary key from looking at that. Okay, we're done creating this table, so we can close this designer tab. Now we need to add some test data to our inventory table. So we can do that right here using SQL Server Management Studio. if you can see your inventory table, right-click on it and choose Edit Top 200 Rows. Now this is going to take us into an edit mode. Edit Top 200 Rows. Do you see it?
Yeah.
Okay, so our first caller ID column, if you notice, it's grayed out. If you try to type there, you're going to get some rejection because we said the caller ID was automatically created. So we don't want to type there. So just press Tab to go into your Make field. And now you should be able to type something. This first car is going to be a VW. Notice as soon as I type that, it puts a new empty row below. Don't worry about that. Now, as I tab across, I'm going to see some red exclamation points warning me about errors. Those are going to go away as I type data. I'm going to say it's a black Volkswagen and its pet name is Zippy. Now I can press enter here to add that row, or I can press tab to go on down to the next row and add that one. Notice our first car, Zippy, got that car ID 10,025 that we said was our seed value. Now I'm going to tab again to create some more test data. We want a Ford, and it's a color rust, and we're going to name it Rusty. My dad here in a couple of weeks is having a big auction selling all of his old cars and stuff. So if you're into old cars, you should go. He has some Model T Fords and Model A Fords and weird other cars that are on this list. Okay, our third car is a Saab, and it's black, and they call it Mel. I don't know why. Next, we have a Hugo. It's called Clunker. There's an old Danny DeVito movie where a whole town gets free Hugos, and they drive them till they're all dead, which doesn't take very long.
Is that all the cars are dead or all the, town?
All in the town, because they give everybody in the town a free car. So they're all driving the Hugos. Yeah, in like 3 months, they're all on foot. Okay, this car lot likes BMWs. We have a black BMW named Bimmer, or nicknamed Bimmer. And then we have a green BMW named Hank. And then we have a pink BMW named Pinky. That must have been a Mary Kay car or something. All right, there's all our cars for our inventory. My dad is actually selling a lot more cars than that. He has some of the old half-track things that run on a track that my brother says would be good at Comic-Cons and stuff for pictures. All right, how's everybody doing? You got data? Problems?
Yeah.
Yeah? What's the matter?
My car ID, I have no idea what it's doing.
So we could use our rows, we could say
Oh, I think it's updating by 10,005. Starting at 10,025. So you're okay. Those are the kinds of things that are very large and change. But you'll have a big part of that. Anybody else got it? You can add your favorite car if you want. I'm going to add Beyonce because she makes me mad. Okay, if your test data is done, let's close that tab. And now we have something really special to create. Whenever we're working with our inventory table, we would like people to be able to pass in a car ID and get back the pet name. So we're going to create a program snippet, basically, called a stored procedure that's going to be saved in our database. So we want to look at this programmability area, expand it, and click on stored procedures. Now we want to create a new one. So when you right click on that, choose stored procedure again. Now whenever we do that, SQL Server Management Studio is going to give us this giant template of a stored procedure. And it's really nice, has all sorts of comments and stuff in it. Let's Control A and delete that.
What did you do?
Stored procedures.
Right click.
And just click on this one.
Yeah.
Mhm.
Okay. That's it like this.
Now delete that template because we're just going to create our own. And we're just going to put the syntax that they give us in the textbook, because this is kind of database knowledge that we'll take advantage of. Our stored procedure is going to be called get pet name. Our stored procedure is going to use two variables. Whenever we create variables in a stored procedure, we put an @ sign as the first character. Our car ID variable is going to be an integer. And then we're going to have a pet name variable. And we are going to say its character up to 50, because that was how big our data field was. And then we're going to tell the system that this field is going to be used for output. So those are our variables that we're going to use in this stored procedure. Now our stored procedure is just this one line of code under the keyword as. It's going to be a select statement. And we're going to say that we want to select into our pet name variable the pet name from our inventory table. Where the car ID on our inventory table equals the car ID that's passed to this stored procedure. So although we don't completely understand a lot about what's going on here, we do know enough that we can follow the instructions and create this stored procedure. We're going to use it in our C# code, and that's where it's going to matter that we have a complete understanding of things, of what it does. So all this stored procedure is going to return is going to be one pet name. Now let's save it in our database. Right now it's not saved. I can click execute to run all these statements, which are going to create this stored procedure with these variables in this select statement. Now I should get this nice message, commands completed successfully. And now in my Object Explorer, if I refresh, I should be able to see that stored procedure under my stored procedures, get pet name. Do you see it?
Yeah.
How you doing?
My procedure doesn't recognize that inventory as a table.
Whenever we're using the server, whatever we're clicked on over here in this object browser is kind of our current database. but we can specify what database to use with the use statement. So let's try that if you're having any errors. Make sure it knows what database to put that in. I'm always in my
I was worried that requires the.
Sometimes the management studio gets really messed up. Your number without your name, zero.
Whoa.
What'd you do?
Now I'm going back to. Where am I?
Do,
Okay, now what was the part you did?
execute. And then
Interesting.
don't look at those system ones.
No.
That's what Jay did, was look at those system ones.
So the problem was that it was all correct. And
The problem was it was all correct, and that's when you should
that's the
close
problem.
SQL Management Studio and open it again,
That's
because
why
sometimes it's not that
SQL
smart.
homework is so terrible. All right.
It's all right, it doesn't work. Yeah, sometimes the IDE is not very intelligent.
Yeah, it didn't like rerunning it.
Like for example, my.
Do I?
You have to save it before you run it.
No.
You know, well, I did it, and it says there's another one.
Oh, because these already exist.
Yeah, because it already exists.
Yeah,
It won't
you can't run it.
Oh, so you're okay.
Yeah.
So yeah, if we wanted to update this stored procedure, what we would do is drop it and then create it again with the changes. So we would always be dropping and recreating because the modify doesn't work super well. So, okay, our stored procedure is created. We're going to come back to that whenever we use it someday. But for now, good job. That's kind of like if you run into, I don't know, when you guys were 13 and would run into instructions that told you you had to use the command prompt. You wouldn't know what you were doing, but you could get it done. Okay, so I'm going to close this tab. I don't need to change it or to save it. Now I could if I wanted to, but it's no big deal. Now, we created the stored procedure using typed syntax like code. Let's create a table the same way. So let's open a new query window. And again, in my query window, I'm going to specify what database to use first. What you got?
How do you update the stored procedure? They got this. Still gotta start next to it. I don't want to close it. I added this part. After it's,
Oh, you're okay. Yeah, you're okay.
because it says it's not in the files. I just don't
Yeah.
know. So where are we at? So what is the semicolon for in this?
It's the end of a command, and you'll see that a lot of times you don't need it, but if you just use it, it'll be safer than if you don't. So it's kind of flexible.
The flexibility annoys me. That
Always use a semicolon.
well, like whenever I was in GML, I had trouble because I couldn't remember when I was and wasn't allowed to use
Yeah,
it.
we just always use one. So we can't use it for the go though.
Go shoot.
Those could be capitalized.
Oh, it doesn't matter.
It doesn't matter.
Just
All
so
these
you-
capital letters everywhere.
Just so you can tell what's command, what's not.
I'm doing a textbook, and they want all of the table names all capitalized. Yuck.
Why not do everything well?
I don't know.
My columns capitalized differently every time. I'm not sure. Is there some sort of way I'm supposed to do my columns? So I just camel case, all caps, no caps. I'm gonna need feedback from my professor on what.
I think that it should be camel case starting with uppercase letter, but that's just the way the place I worked at did it. So that's just a,
I'll just ask whatever you're working.
yeah, I think that if she's not saying, then it doesn't matter.
The first machines I used,
Uh,
everything was uppercase
everything was uppercase.
because there was no lowercase on the keyboard.
So that pretty much decided it. Okay, let's create our customers table. So we're going to use DDL syntax, data definition language syntax, to create this customer table. So we're going to start out with the create table keywords and then our table name. Our table is going to be customers. And after the table name, we want to open parenthesis and a close parenthesis.
Is this a code version of what we just did? The inventory table? Or-
Yes, it will be exactly the same except the code version. Now for our table, the first column we want is cust ID. We're going to put it in square brackets because anything we enclose in square brackets tells SQL to keep it exactly as we type it. So even if it was a keyword or included spaces or some other sort of illegal character, we would be able to do that if we put it within these square braces. So we're going to say our cust ID column is an integer and its identity, because we want the database to automatically assign values. We want to start at 1 and we want to increment by 1, and it cannot be null. Next column, first name, is going to be that n bar char for 50, and it can be null. In our textbook, they have a space before the comma. I'll put that on that first line too. I think just for clarity to see where that ends. Our last name column is again going to be the same data type, and we will allow nulls. Now that's it for our columns, but we do need to specify what our primary key is. Our primary key is our customer ID. And we're going to cluster our data by that customer ID. So that just means that customer number 2 will be close on the disk space to customer ID 1, and it will be close to customer ID 3, so that if I wanted to select everything by customer ID, I would be hitting the same part of the disk drive. That's what clustered is. And they're going to be clustered in an ascending sequence.
Does this QL allow comments?
Uh-huh. So we can put comments as like 2 hyphens. This will create the customers table. And then you can also do, I think, //star for a block comment. Or is it just 1 slash? Sorry, I always use the hyphen. Oh, just 1 slash, okay. Kind of like HTML comment. Now I haven't executed this yet, so I still don't have a customers table. Once I execute it, my customers table will exist and it will have these data elements. If I wanted to change it with the code, again, I would add a line of code to drop table customers right before my create.
Would it be good practice to like always include that, just in case?
Lots of people do, like they'll go ahead and put the drop in. So you can, if you want to. I'm going to show you how to generate this code if you don't have it. So I want to run this one. I'm gonna put an error in here, okay? Not that I would ever make an error as a DBA. I'm gonna leave the A out of the last name. And now I'm gonna execute this. Now I'm all done. I'm gonna look over in my object browser, make sure that my customers table was created. Yep, I have it. So I'm gonna close out. Nah, I don't need to save it. I got it created. It's right, right? I never make mistakes.
I didn't get that.
Yeah, mine.
Nothing, tables, or-
Didn't do it? What'd it do?
I executed it and it says there's already object named customers in database, but I can't find the data, or I can't find the table. for that.
Oh, do the refresh again, like a bunch of times. Sometimes it can take a whole bunch of times before it shows it to you.
This game was. If you minimize the database folder
Uh-huh,
and then refresh.
that'll do it better.
Yeah.
There it
Oh.
is. So, sometimes you have to close it all.
I didn't misspell the name, though.
That's okay. Now, you should be able to look at the object browser at your columns. Now, I misspelled that name intentionally because I wanted to show you what I would do. Now, I don't have that code anymore because I closed out of that window. No problem. On my table or any database entity that I have, I can right click and choose script table as. Now, what script table as means is generate the code to create this table or drop this table or whatever. I'm going to generate a script to create this table, and I would like the script placed in a new query editor window. When I do that, I get all the code for me from the database. So it's got a little bit of extra stuff, some things that were defaults. But now, if I want to fix a problem, I can drop table customers. Then I'm going to say go, because a drop is going to do stuff. And then I can create it, and I can fix my error. So I'll fix my error. It's mad at me. Try and run it. And even though it was complaining about that table, it completed successfully. So sometimes we just have to be smarter than the tool we're working with, right? Now I'm going to refresh my customers table and see if that, make sure that change went through. And sure enough, now my last name is typed correctly. So anytime you need to know what the code is for anything that's in the database, you can just right click on it and choose script as, and that will generate the code to recreate that item. Questions about that? That's a pretty important feature because you can generate your code for anything.
But crashed the program trying to generate it, though.
Well, it's just a little slow. It's fine. It made it. Speaking of crashing the program, we will hear in just a moment. But first, let's add some data to our customers table. Are you ready?
created. Yes.
It just takes a really long time to refresh it. So that's what was happening that like, it really, you don't believe it. You're like, no, it just didn't work. It just didn't work. Sometimes it's just faster to close out of the management studio and reopen it if it's giving you a hard time. Okay, so we've got our two tables created. I'm going to close this tab.
You know, all of my stuff from the last one took this is still there. All my queries that I did in 2 steps.
Oh, because you saved them onto your flash drive?
No, I saved them on.
Because it's a whole brand new world database. It shouldn't know anything about your past.
Well,
If it does, I want to know what magic I did, because that's creepy.
but I got chapter 4, the X1, SQL. Yeah.
Chapter 10 stuff.
These were done in 2018.
I still have some of that stuff too. I mean, it doesn't work on this database. I saw that stuff stay.
I don't know why you have it. Let's create customers. Right click on your customers and say, edit top 200 rows.
But if you want to edit more than 200, is it
You can only do 200 at a time.
This isn't an editing software.
Right, it's really just for test data. You'd write a query or something to insert into it. Okay, so our first customer is going to be Dave Brenner. And again, I'm just pressing tab, and Matt Walton, and Steve Hagen. Now, the way we created that table with code is definitely an option. I think that our car dealership is in Bentonville or something. We have a lot of Waltons as customers. That's good, right? But whenever we type all of that code up to create our table, create our database, you saw I could generate that code just super easy. It doesn't matter to me whether you type it in as a create table statement or whether you use the GUI, because you can get to that code. But as a DBA or somebody who creates databases all the time, you're going to get to type really, really fast because you do use a lot of that code. So that's just an important thing, that you use the tool that's going to meet the need. So if I need to create a table really fast and I'm not sure what it's going to have in it, I might use the GUI just to create discussion points. But if I know exactly what's going to be in a table, I'll just use the code to create it. Okay, you got your customers created. We need to create one more table. This is our link table that links our customers to the inventory that they bought. So I can close this tab. And let's create a new query. And
Sorry.
you're fine.
Where's this like little snippets of code that you're sending to the database to make it use the
Yes, exactly. And when it first started, Alex, a query was just a select statement, just like a query to the database. Who's the oldest customer we have? Tell me, and the database would tell you. And over time, query has evolved to include all of these statements where we're creating tables and doing things that aren't actually queries, but they're still considered a query window. So let's use your database. We're going to do the create table statement again. And this table is going to be orders. Now in our orders table, we want an order ID. And it's going to be an integer, not null. And it's going to be our primary key and our identity column. Notice how we handled this primary key differently than the way we did it with the previous table. So there are differences in syntax that is allowed. Now our customer ID is an integer, and we can't have an order without a customer ID, so we're not going to allow nulls in it. And lastly, our car ID, again, was an integer, but we can't allow nulls.
Don't we have to make some for it?
Hmm?
How would you make some for it?
We're going to do it in our database diagram. We'll see if that works. It did not work so good this morning, so we'll see. Now, right now, shouldn't I put identity on this customer ID and car ID? I thought we said these were identities. No, why not? They're foreign. They're already going to have a number, right? We already have the car with its ID or the customer with its ID in that right table. Those fields, those columns are identity in the table where they'll be created, not in this orders table. In this orders table, the only column that will be created is a unique key, is our order ID. Okay, so we're ready to run this. Let's create this table. And it worked. If you get messages down here that it completed successfully, that's what we want. Now click on tables and refresh. If you notice, if you're not exactly clicked on tables, you might not get your tables refreshed. You might get something else refreshed.
You think I didn't refresh, but because refresh.
Yeah, you would think, huh?
If it's for really, really big stuff where.
Exactly. It's so big that you might not want to refresh the whole thing. That's exactly right. Because we could have, was it, I think Yahoo, the last time I researched, Yahoo used SQL Server for their database for all of their users and stuff. So, I mean, we're talking really huge, huge, huge databases that are on SQL Server. Google's probably using their own now. They probably don't use this one anymore. I don't know. Okay, everybody got it created all right? Got orders? Let's put some test data in there. If you can see your table, right click on it and let's edit those top 200 rows just to add a little test data. Now to add our test data, we're going to need our customer ID and our car ID. And remember, we made our car ID start at that 10,025. So we'll have to be a little creative here. Customer ID 1 in our book bought car number 5. So that's going to be 10,030. Customer number 2 bought car ID 1, 10,025. Customer ID 3 bought car number 4, so that would be 10,029. Austin, how are you doing? You what? Oh, okay. I liked it. Our last customer ID 4, bought car number 7, which would be 10,032 in our interesting scheme of things.
Wonder what
That's-
happen if you put 10,050.
Well, try it. That's a really good thought. Let's see, in our customer table, we went up to customer number 4. So I could try 5, and then I'll do a car that exists, 31. And let me take it, because we haven't told the database about the referential integrity rules yet. So that's what we're going to do next. We added our data before we made those rules so that our data would be easy to type in. But now that means as we enter our rules, our data better go along with those rules or we could have trouble. I'm going to delete this last one and we'll come back and put that in again after we've added in our relationships. So let's add those relationships. I'm going to close this tab. We have test data in all 3 of our tables. We have all three of our tables saved. So we want to create the relationships. We can do that in a lot of ways, but our textbook wants us to use the database diagram, and that's a good way. So up here, right under your username of your database, double-click on database diagrams. You should get this question. Do you wish to create these things? Say yes. We want to create this stuff. Now, when we've done this in the 250 class, it's just crashed like crazy, but it's working for this little one. Now I want to actually right-click here and choose New Database Diagram. We could add tables to our diagram, and I want to add all three. So I'm going to shift-click to select them all and choose Add. We'll see it work grinding away for a little bit here as it adds them to our picture. I used Visio to create that database diagram that I showed you, that ER diagram. But SQL Server will create a little bit of one for us too. So, or it wouldn't at the beginning of the semester, but it will now. So now we can create our relationships. So our relationships are that from my order table, my order ID is connected to, oops, that's the wrong column. My customer ID is connected to my customer ID on my customer table, and my car ID is connected to my car ID on my inventory table. I want to rearrange these. I don't like them the way they are. I'm going to put my customers on one side, my orders here, and my inventory here, and you can arrange it however you like. So to create this relationship, I'm going to tell the database that I'm going to start with the customer table. I'm going to click on customer ID, and I'm going to, in this little area over here with this triangle, I'm going to click and hold, and I'm going to drag that customer ID onto the customer ID of my orders table. Now when I drop it, I should see this tables and columns window. It's got everything already set. It says this relationship is going to be called F key for foreign key, order customers. My primary table, my owner, is the customers. That's correct. My foreign key table, my child, is orders, and they're connected by customer ID. That looks right. So I'm going to click OK. Now, on this screen, there are some other things I need to check. First of all, under this general section, notice it says that it's going to automatically check existing data on creation. That's what's going to keep us from adding an order that has an invalid customer.
Both sides of a relationship must have the same number of columns.
Your orders doesn't have cancel. Start with this. Hold and drop it down. There we go.
Oh, okay.
It's that dragging and dropping. Okay, now we need to change one thing though here. Besides checking for existing data, we want to update this insert and update specification. Right now under delete rule, it says no action. We want to change that to cascade. What that means is if we delete a customer, we're going to cascade and automatically delete all of their orders. Okay, we're not going to leave orders out there without a customer ID. Then for update, we're going to do the same thing. If we change a customer data that matters on all those orders, we're going to change all those orders. We don't have anything that would matter, but if we did. And then we're ready to click OK. So now that relationship is created. We could have created it in our code when we created the table. And actually the database diagram will do that for us when we close. Now let's create the relationship between our inventory and our order. We need to grab our car ID, drag and drop it on our car ID on our orders table. Make sure that we've got inventory as our primary key table and orders as the foreign key. Click OK. We need to change the insert and update to cascade. Cascade and OK. Now you can change and rearrange that database diagram however you like, however you want to look at it. That's what matters. A lot of people, when you think of a database diagram like this, two primary tables with a link table, this is a really common structure. A lot of people like to have that link table in the middle. A lot of people like to have it in the middle of a vertical stack. Totally up to you. So you can move it around however you like. Look good? Now when we save it is when the database management system is going to try to update our tables to define these relationships. So let's save this.
After you added the foreign keys and everything, what did you do in the relationship?
In the relationships, now if you want to get back to it, you can click on that bar that connects the two and right click. You can delete the relationship or you can go to properties. What we did is under insert and update, we changed the rule to cascade
The update rule.
and delete rule
Okay, I gotcha. All right.
for both of them. Okay, if your relationships are good, right click on your tab and save your diagram. Now we want to call this, let me see what they said. AutoLot diagram, because this is our car lot. Now it's saving our picture, but it's also altering our tables to say that we have those relationships. It says, do you want to save these changes? Yup, I do. Now I've got a problem with my car ID. It says the alter table statement conflicted with the foreign key constraint. So somehow I've got something wrong. Let me check it. It's mad at me. I'm going to click OK. Now I'm going to leave my diagram here and I'm going to go look at that inventory table. I'm going to right click because somehow I got off and I created an order with a car ID that doesn't exist. That's why I'm getting that error, I think. So my inventory, instead of edit top 200, and I'll just say edit top 200, then I can change them if I want to. Okay, so those are the car IDs I have. Then I'm going to do the same thing with my orders, edit top 200. And I'm go, oh, there's my problem. I have the customer ID 4 bought car 10,032, and we don't have a 10,032. So I will make that 10,031. And that's the way work always is. It's always those little teeny things that the boss throws at you at the end that cause trouble. I don't want it to start at 1. Okay, I'm going to go down to the next row to make sure my change is saved. And I'm going to close my orders table. Close my inventory table because I found my problem. And I'm going to try to save my diagram again.
I didn't know that problem because I created the t-shirt too.
Oh, there you're good.
Uh,
Yay, did it.
You said if you wanted to throw in your own vehicle.
You could, oh, you added a vehicle. Good job. Okay, now, if you look, you should have a database diagram. Did it save for you? Mine is saved, so I think everything is out there good. I'm gonna stop here for a small amount of last time. Took you for a little bit more. It took a little longer. You okay, David? So if you're all set, that was what I wanted to do today. So next time on Monday, now you guys have all the info you need for that assignment. You can start looking at it because you're going to create a table and create a class file. So you should have everything that you need. That doesn't mean you won't have questions though. But Monday we'll be doing a lot of coding. So we're going to go through and access these databases that we've created.
So we
Yeah, and the way the book shows us how we're gonna have it varied too. So they do everything like nobody's working. It's like it's
I think it's.
Did it start in Kansas City? Oh, you know, it could be, it could be. That's internet. Get me slow. Guys got it? If you got it, you're on lab time. You can finish that thing up or get started looking at that one for next week. You ready? It's always been so I think it's nice.
You have to use Excel.
So, it's just one of those things where I was telling them this morning, it's like when I used to teach business maintenance. You always have to be like, just hang in there because we're gonna come back around and fill in these blanks because you're always gonna have some blanks.
Am I here?
Are you here?
What are you having trouble with?
Yeah.
Right now, like I'm trying to do like setting up an Excel document like this line. Like okay, I want to get it. Right. Wait. So then my next week code.
And then it's like,
XSS doc and
just been slow and school and work.
It is mine.
My dog was saying.
So you got the first line right, but like you're gonna have to know where you're wanting to load from for each read and so like I just copied a little bit.
I want to use this inside the end of I can do it here. I don't know what to do.
Yeah.
So obviously, but you're gonna have to do
So, right, the thing is, I want to get to back now, like my own, so I don't want to have only, valid here. That's kind of my, that's why I'm holding
What's that
myself.
company called? Stabilize?
I've used it.
Does anybody know anything
Like
about it?
all in
What?
separate things as well.
That's like a new, you
Yeah, I'm redefining it. Yeah, I'm redefining different areas.
Yeah.
So that's not a problem.
Yeah, it doesn't, I
It's
redefine
definitely
it
more
almost every statement, so that way it would probably work.
Oh. So I guess I may just not be working. Because when we did it in morning class, it would like completely crash.
So close everything and start again.
Don't close everything. That's that transfer.
The other thing is I don't want, if you can read all of that, you want to choose this to save at the end. It's all in, it'll override everything. It'll just override it all. But those are those two basics, the basics down. Otherwise, I wouldn't even bother saying on those together. The whole thing, I wasn't reading a whole lot.
I like kept my saving tickets like example, what I wanted to do is create like a list of 25 of them and then have like an indicator on each one. It's like, is it occupied or not? And that's, I was like, I had so many different ways I wanted to program the work.
That's why I did that, but I used buttons.
Yeah.
So like green is you can click on, we have to order the ticket. Click on it.
Interesting.
Submit it, and it's done, in 3 hours before it goes from us. But then when I close it out, that's gonna be right next time I go in. So, but yeah,
I gotcha.
You got me on.
There's just so many.
Figured out what you look like.
Yeah, there are just so many options. I felt like on how you do things I should decide what I wanted to do. I was like, do I want to get clocks or do I want to get a customer to tell me how to take part here? Should I do like that? Like just weird stuff that's not relevant to the actual assignment, but is important for actually coding.
For making a legit one.
Right.